Good morning, children. In the last class, we have discussed about the Newton's first law of motion. And we have already discussed about the inertia also in the last class, that inertia of rest and inertia of motion. So according to the Newton's first law of motion, so a body which is in the state of rest continues to be in the state of rest, and a body which is in the state of motion continues to be in the state of motion until and unless some external unbalanced force is applied to change the state. So it is also known as the inertia of law of inertia, as we have already discussed, that how giving an example that how a body which is in the state of rest, it wants to be in the state of rest, and how a body in the state of motion wants to be in the state of motion. So that property is actually known as inertia. So therefore the Newton's first law of motion is also known as law of inertia. Now inertia and mass. Inertia is, so how we can define inertia? So inertia, it can be defined as the property of all the bodies, the properties of all the bodies or objects by virtue of which they are unable to change their state of rest or of uniform motion in a straight line without the help of an external force. That means the property of the bodies by virtue of which they are unable to change their state of rest or uniform motion in a straight line without the help of an external force. That means until and unless we apply an external force to a body which is in the state of rest, it will continue to be in the state of rest, and a body which is in the state of motion, it will continue to be in the state of motion. So that is known as inertia. Now a note that heavier or more massive objects offer larger inertia. Hence the inertia of an object, if the object is heavier or massive, it offers more inertia. So hence the inertia of an object is measured by its mass. If the object is massive, huge, so it will have a greater mass, and hence it will have a greater inertia. So the second law of motion. So before we start the second law of motion, we must know what is actually momentum. So the momentum P, which is denoted by small p, of an object is defined as the product of its mass m and the velocity small v. That is, P is equals to m into v. That means if the mass of the object is given and also the velocity of the object is given, so we can find the momentum. So that means momentum is equals to mass multiplied by the velocity of the object. The momentum has both direction as well as magnitude. This momentum has got both direction as well as magnitude. So therefore it is a vector quantity. Its direction is same as that of velocity v. So this momentum is a vector quantity since it has got both magnitude and a direction, and the direction is same as that of the velocity v. The SI unit of momentum is kg meter per second, because we know the SI unit of mass is kg and the SI unit of velocity is meter per second. Therefore the SI unit of momentum is kg meter per second. So this is the SI unit of momentum. Now the second law. What is the second law of motion? The rate of change of momentum is directly proportional to the applied unbalanced force and takes place in the direction of the force. So according to this law, the rate of change of momentum is directly proportional to the applied unbalanced force, and it takes place in the direction of the force. So let's understand the mathematical deduction of this second law of motion. That is mathematical deduction for second law of motion. So let m be the mass of the object, let u be the initial velocity, it is the initial velocity of the object, v be the final velocity of the object, then F be the unbalanced force, that is applied unbalanced force. So this is the force which is applied force, and T is the time. Now therefore the change in momentum, we know that the formula to find the momentum of an object is small p is equals to m v. Then what will be the change in momentum? So therefore the change in momentum, so therefore the change in momentum is p2 minus p1. That means this is the final momentum and this is the initial momentum. Therefore the change in momentum is equals to p2 minus p1. Now we know the value to find the value of momentum, that is mv. So since this is the final momentum, so therefore mv is the therefore we take the velocity, that is the final velocity, since this is the final momentum, and since this is the initial momentum, we will take the initial velocity, that is u. So m we can take common, so it will be v minus u. Now therefore the rate of change of momentum, since rate of change in momentum, now we need to find the rate of change in momentum. Rate of change in momentum. So what will be the rate of change of momentum? So it will be m v minus u whole divided by t. So since we are saying about the rate, so therefore we need to divide it by t. Therefore the rate of, this is the change of momentum, and since we are talking about the rate, so therefore we need to divide this change in momentum by t. So this is the rate of change of momentum. Now according to the second law, according to the second law of motion, it is given that rate of change of momentum, so as it is already given in the statement, that the rate of change of momentum is directly proportional to the applied unbalanced force and takes place in the direction of the force. So rate of change of momentum is directly proportional to the applied unbalanced force. Now this is the rate of change of momentum and this is the unbalanced force. So therefore according to second law, to the second law, we can write that F is directly proportional to the rate of change of momentum. That means this. Now we already know, if we replace this proportionality sign by equal sign, then that means we need to take one constant here. So if we replace this proportionality sign by equal sign, we need to give one constant, say k, mv minus u. So here k is the constant of proportionality, so it is the constant of proportionality. So this is the constant of proportionality. So therefore we can write F is equals to k. Now we know this is the value of m comes here, so this is the value of acceleration, v minus u whole divided by t. So this is the value of acceleration. So here we can write, in place of this v minus u whole divided by t, we can write a. So therefore F is equals to k dot m dot a. So let this be the first equation. Now if unit force is chosen to be the force which produces a unit acceleration in a unit mass. Now if we choose the force to be a unit, that means a unit force is chosen which produces an acceleration of a unit, which produces an unit acceleration in a unit mass. That means the value of F is also we have taken as 1, then m also as 1, and if a is also 1, then the value of k will be 1. So in this case, if a unit force is chosen, so we have taken the unit force to be the force which produces a unit acceleration, in a unit mass. So this acceleration is also unit and the mass is also an unit mass. So in a unit mass, then the value of k will be 1. Now if we put the value of k equals 1 in equation 1, what will happen? Then equation 1 implies what? So this becomes 1, so therefore value of F is equals to ma. So this is the mathematical deduction of second law of motion, that is F is equals to ma. force is equals to mass multiplied by acceleration. And the unit of force, so in this manner we can find the force. If the mass of an object is given and the acceleration is also given, so we can find the force applied on that object. The unit of force is Newton. The SI unit of force is Newton. So represented by capital N. So the unit of force is Newton, and which is represented by capital N. So this is the second law of motion, and as we can see, so this is the mathematical deduction for the second law of motion. So that's all for today. Remaining we'll discuss in the next class. Thank you.